Fine, welcome again. So just now I was playing with the Raspberry Pi Pico microcontroller and the RS module. Okay, so since they using the UART to communicate with each other, so I thought that it would be better to start with understanding the UART communication with the Pico first. So that's why I come out with this video where we will talk between or send data between Raspberry Pi Pico and the Arduino UNO using the UART. Okay, so I will explain to you guys the UART communication protocols and all the setup for the Pico first. Then we will talk about the RS communication or the Modbus, this module. Okay, so here I have Arduino UNO, Raspberry Pi Pico wireless, and the logic converter. Why we need the logic converter? Because the Raspberry Pi, as you know guys, it's work only with 3.3 volt, and the Arduino is a 5 volt. The I/O support 5 volts, so that's why we need the logic converter to convert between 3 volt and 5 volts. Okay, so let's go and check the wiring and continue with the series. Well, so now we have reached to the wiring of today's video. As we said previously, we will use Arduino UNO and Raspberry Pi Pico to exchange the data between them using the UART. Okay, so let's start with the Raspberry Pi Pico. This IOs. So we will use from the Raspberry Pi, we will use the ground, the 3.3 volt V out, and also the 2 pins of the UART, one the TX and RX, which they are GPIO4 and GPIO5. Okay, so here you can see. Let me zoom in. So here is the wiring between the Pico and the logic converter. This is the logic converter, the low side and the high side. Low side will be connected to the 3.3 volt of the Pico, high side will be connected to the 5 volt of the UNO. Okay, as we said, we need the ground 3.3 volt GPIO4, GPIO5, and from UNO we need 10 and 11. Yes, 10 and 11 because we will use the soft serial. Okay, so we will maintain the RX and TX for the USB communication, so we can send the data from the USB to the soft serial. Soft serial will send to the Pico, and Pico will reply again to the soft serial to the USB. Okay, so here it is. So you can see here, this is the high volt side, this is the low volt side. Okay, so the high volt will take the ground and the 5 volt from the Arduino, go to the ground and high voltage to the logic converter, and at the same time we will take number 10 and 11. Number 10 go to channel 1, number 11 go to channel 2. Okay, and at the low side, low volt side, so ground go to ground of the Pico, low volt go to the 3.3 volt, which is pin number 5 on the right. Okay, 5 from the top. And again, the first channel, which is connected to the digital number 10 of the Arduino, will be connected to the GPIO4, which is pin number 5 from the top of the left side of the Pico, and GPIO5 will be connected, or the pin 11 of the Arduino will go through the logic converter and all the way go to the pin number 6 of the left side of the Pico, which is GPIO5. Okay, anyway, if you're confused from the I/O or the wiring here, you can just follow this table, which is exactly what I'm doing in the wiring up there. Okay, again, make sure that the GBIO4 go through the low level, then the high level go to the digital pin number 10, and GBIO5 go to the another channel, and this channel go to the D11. Okay, so now let's move on to see how the wiring will be on the breadboard, and we start with the coding. Okay, here is the wiring done already in the breadboard. So here's the Arduino UNO. You can see here the 5 volt and the ground go all the way to the logic converter, then to the high side of the logic converter. Then this one is D10 and D11, which is representing the software or soft serial, will go also to channel 1 and 2 respectively of the high side of the logic converter. Then on the low side of the logic converter, I took ground and the 3.3 volt from the Pico go to the logic converter, and the low side of D10, okay, will go to GBIO4, and D11 will go to GBIO5. Okay, here's the wiring is done. You can see here this is 10 and 11. Try to rotate. Okay, pin 10 and 11 come to the logic converter, and logic converter go to here. These two for the power, ground and 3.3 volt, and this one the UART channel, which is GBIO 4 and 5. Okay, let's go and do the coding. Okay, here we go. So we have reached to the coding part. So here I'll start with the Pico first. Okay. So what we need for Pico? So we need to import from machine. So first we need to import in and UART. This is the most important packages that we need, and also we need to import time, because we need to use time to set the microcontroller to sleep. So let's save it. Okay, by the way, I have already saved this script as a main.py and inside the Raspberry Pi. So okay, so next we need to initiate the UART. So here's how we initiated UART equal to capital UART. So again, as we said, we were working with UART1 with the out rate of 900 should be fine, and the TX pin should be pin number GBIO4 or pin number 4, and the RX pin should be pin number 5 or GBIO5. Okay, that's good. So then let's print out something so we make sure that our code is okay. So we will print Pico ready. So that's one. There we go. Pico ready is mean everything okay. All the few lines, only one line is being okay, right? Okay, what next? So we need to have a loop so we can continuously listen to the UART in case we receive any data at any time. So we need to have a while loop. While true, it's always true. So we need to continuously listen and monitor the UART. So we will check if UART got any data, then we will try to read it. So our data will be equal to UART.read. Okay, we will read the data in case there is any data coming from the UART. Okay, so then I'll print the data. So print the what they call receive data from UNO. This one should be in double quotations. Okay, space UNO plus data, and this data could be integers. So that's why I'm better to add string to make it easy to concatenate for the Python. Okay, so now we will continuously monitor the UART. If we got any incoming data, then we will read it. Then we need to add some time so that the CPU go to sleep, or like we need time dot sleep 700 seconds should be fine. Let's run again. If we have no issue, then we should see Pico ready and is continuous running now here. Okay, so now this is the early or the first step of the Pico. Before we go further and analyze the data and do whatever we want to do, let's go and do something for the UNO and try to send some data, and we see whether we can get it here or not. Okay, so now for the UNO, I already create new sketch. Okay, so first thing we need to do in UNO is to include #include the soft serial software serial.h. Okay, then we need to declare our soft serial object. So software serial, I guess just copy this guy, soft serial of say my serial with RX pin 10 and TX pin 11. Okay, so let's compile and see. Hopefully we didn't do any funny mistakes. Here we go, it's compiling, done, good. Okay, so we're good so far. What we want to do. So here in the setup, we need to first declare our serial or the main serial. So we need to begin it with the baud rate of 9600, and at the same time we will begin our soft serial with the same baud rate. Okay, that's good. Let's compile it. And also I would like to add serial.print line, yes, I want to print that UNO ready. Okay, good. Let's compile. Should be good. Yeah, and upload. Here we go. So now if we open the UART, I should see UNO is ready. But for sure we haven't sent anything to the Pico yet. So how to send data to the Pico? So here I will send data to Pico, let's say inside the while loop, because I want to continuously check if I send anything from the main serial, then I'll send to the soft serial. Okay, so I need to write my code here. So here I will say sending data to Pico. So first I will check if and only if there is a serial available, okay, if there's any data from the serial, then I will do what? I will take my serial dot write. I will write the data to my serial, which is what I will write. I'll write whatever I read from the main serial. So this is the Pico serial. Then I will read from the main serial. So serial.read. Okay. So here, again, first I will check the serial. If there's any data coming from the serial, so I will read it and write it back to the soft serial that I will send to the Pico, exactly like this. Let's compile and upload so we can do some testing. Okay, here we go. Our UNO is ready. Now let's start to send some data. And if you see in the background, our Pico also ready. Let's send A. Here we go. Haha, receive data from UNO. But for sure, we have like some headers, like the carriage return and the new line and all these things. So if I send AS, here we go. So whatever I send now, it will be go there. Hello from Pico or from UNO, sorry. Here we go. Hello from UNO. Okay. So, but for me, it's a good practice actually to add some delay here. For some reason, sometimes I notice that the communication might be not that good, or not communication. How can I say there's an issue happen if the communication will be very fast, so it's good to add some delay. So it's a good practice to add a delay here. 1 millisecond. Okay, let's upload. Okay, so now let's test for the last time. Here we go, done, yeah. Hello again. Hello again. Okay, good. So now let's come here and arrange our data, or what we call prepare our data, make it more readable instead of all this garbage that's been surrounding our data. Okay. So first thing I will do is to decode and strip the data. Okay. So since I got this one, so I will come here, then I will have another decoded data equal to the data itself, my data dot decode, and also I will strip it. Here we go. Okay, I decoded and stripped it, so now I can bring the new data. If I copy this thing here, so now I can receive the decoded data from UNO is decoded data. Here we go, it's ready now. So now I will open the sketch again. Let's try to send hello. Here we go. If you can see here, let me bring this up. Okay, now it's okay. So we see here the raw data, I can say, got these extra headers here. And after I decode it and strip it, I can get the exact data that I send it from UNO. Send again. What's whatever. Okay, so far we are doing good, so let's move on. So now looks like the communication okay and everything goes fine. I want to add some complexity to my code. Okay, I want to add complexity to my code. The complexity will be like this. I already sent data from the UNO to the Pico, but I want Pico to send back the same message with an extra data, which is, for example, a counter. So I will declare a counter. Let's say here, counter equals to 0. Then I want the Pico to send data back. So here, send back the data to UNO. Okay. So before I send back the data, what I want to do, I want to prepare my reply. My reply message will be the decoded data, the exact same data. I will send it back. Plus, I will add the counter. Where is my counter? Plus the counter. But for sure, I cannot edit like this. I need to convert it to string. Here we go. Okay. So I want the data plus the counter. But let's add a space here. And add a plus. Okay. Here I'll add underscore. And for sure at the end, we keep it for the time being like this. Okay, so I want to see how the reply will look like. So reply, oh, not reply, so it will be print. Pico reply is this. And for sure, this one is a string, so should be okay directly concatenated like this. Okay, let's test it out. Everything is fine. So I will say hello again. Here we go. So my reply will be hello 0. I'll send again. Hello 2. Here we go. Hello 2, but it's still 0. I forgot to increase my counter, sorry. So here I will add counter plus equal 1. Yep, so here I believe the counter should be increased with every message. So I say, hey 1. What does say? Who is that? It's 2. What's 3? Here we go. So whenever we send a message, okay, it will be increased 4, 5. Okay, that's good. So now we need to send back this one to the Arduino UNO. Okay, so to send back our reply is as easy as we need to UART.writeBack reply. That's it. So this command will send back the data to the UNO. So now if I come to here, hello. So I expect there's a data coming back from the Pico, but for sure we haven't checked it yet. That's why we cannot see any data coming. So now let's add the data, the data that's been coming from the Arduino Pico. So now we have another part. We come to the UNO. We add the part of print the received data from Pico. Okay, how to print the data? So again, first we need to keep listening. If my serial is available. This means there's a data from my serial. Then I will do what? I will maybe, okay, let me declare a string. Let me declare a string up there. I will call it, let's say here, string receive string, which is empty. Okay, everything okay. Oh, string. Oh, sorry, this one should be capital S. There we go. Let's copy this one and compile. Okay, good. So now I'll declare a string if there is data available from my string. My serial is coming from the Pico, so I will have my string, or the received string will be equal to my serial dot read string. Yes, read string. So I'll read string from the Pico that the one is sent to us. Then I will print it out. So serial.print. Do I have serial.print? I need to print again. Copy this. Make it fast. Let's say here. So here we go. So I will say receive data from Pico. Then I will print the string down here. So line, and also here I'll copy my string. There we go. So if there is a data coming back from the Pico through my serial, I will read it first, then I will print it out on my main serial. Okay, let's download and check if everything okay. Here we go, it's done, looks good. Uno is ready. Hello from Uno. So we send back to here, and here we go, we send back to us again. So we send hello from Uno, come back to here, here we go, hello from Uno is here. Then it adds the counter and send it back again to us. Let's say we send who is that? We send again who is that free, and we send back to us receive data who is that. Okay, so now okay, why like that? Because it will send us the data without new line. So I believe here should be add new line like this. Here we go. So let's test again our code. Hi. Okay, it's sent to us. Hi. Who is that? Who is that to? Here you go, new line. That's should be with number 3. Here we go. Okay, so whenever we send now any data, any rubbish I send, here we go, 4. So now, if you can see here, it's from my main serial, which is from the USB or the hardware serial. It will go to the soft serial, soft serial connected where to the Pico. The Pico process it, add any data we want to add, then send us back through the soft serial. Okay, then inside the Arduino, the soft serial will be read the string, which is here, read the string and print again on the hardware serial, which is here. Okay, so this data coming from Pico. Okay, So if I make this one like this, here we go. So data from UNO, and we'll add the signature or add any counters or any other data and send it back. Okay, cool. So what else we can do? What else? What else? Here we go. What else? Okay, I got an idea to do. So since we have the Arduino UNO and the Pico, they both have LEDs. So I will send from the UNO, let's say if I send on, okay, to the Pico, here we go. So the Pico should turn on the LED, the onboard LED. Okay, when I send off, the Pico should turn off the LED. Okay, how to do this? So first we need to initiate our LED. Let's say initiate our LED. So LED will be equal to machine dot pin, and since this is the wireless one, so will be the built-in LED and machine dot pin dot out. Okay, so at the beginning, while we're initializing our Pico, so I want our LED to be off. Value, so will be 0. Here we go. So I run, should be off. So now if I turn it on, I set it to 1, should be on now. Here we go, it's on. But at the initial state, I want it to be off. Here we go. So off our LED. So now what I want to do, where's our receive data? So this is our receive data. Okay, so here I will check if the data is on to power the LED. Okay, so if the decoded data is equal to on, so I will print, sorry, this one, yes. So first I will print, let's copy this, I'll print LED on here, LED is on, okay, and at the same time I will turn on the LED. Turn on the LED, turn on the LED. So after this, I'll turn on the LED, which is on 1. Okay. So let's test this one. There we go. Open the Arduino. So if I send any data now, you see the, why like this? Okay. Okay, if I send any data now, the data just come back to the UNO without any change. But if I set on, here we go. If you notice, the LED is on. So now if I send off, the LED should be off. So now I'll copy this. Check if the data is off to power off the LED. Here is power on the LED. Okay, to power off. So if this one is equal to off, so LED is off, and the value should be 0. Here we go. So now if I send high, shouldn't do anything. There we go. So if I send on, LED on. If I send off, LED off. Here we go. Okay, this is the first step. Now I want the UNO also to on or off its own LED as well. Okay, so first thing is to check the on and off that's coming from the Pico. But if you notice here, let's say I will on again and off again. If you notice here, you see, whenever I send the command, do you remember we add on the counter? So here is on 2, here on 4, here off 3, here off 5. So whenever I send command, the counter will be increased or counter will be changed. So if I come to here, to the Arduino UNO, then I track or check the reply from Pico, whether it's off or on, to turn on the LED. I can't. Why? Because this number will be also changed, which is, it's not unknown, but I can say not easy to be tracked. So how to solve this issue? How to solve this issue is just that if it's on or off, I will set the reply, I'll copy this. So the reply will be inside here, UART reply, okay? So in conclusion, I will say reply without counter. This is what I'm planning to do. So the reply will be LED is on, and also don't forget to add the new line. And here will be LED is off. Okay, but if I send this, we will get 2 replies. If you see, I can see now. If I send on, I will get 2 replies: LED on and on 1. If I send another off, I will get 2 replies: LED off and off here. Why? Because after the first reply from the on or off, there will be another reply here at this point. So how to prevent this? By just asking the loop to be continue. So this one will not be actually it's opposite way. The continue doesn't mean continue, but it will be go to the next iteration without continue the rest of the code. This is what this means. Continue. So this continue is going to switch to here. It will send this reply, then it won't go down to check the other reply until the next iteration, but it will continue from here and go back to the next iteration, something like this. Okay, so I will go back to here and I will send hey 1 hello. So you see now, if I send any message, any other message, I will get the reply with the 1 and 2 on, etc. If I send on, here we go. So I'll get only this one, only LED is on, that's it. If I set off, so I should get LED off. Hello 2, this is wrong. Shouldn't be like this. So say off. Hello 2 off. Okay, something wrong. Let's check the off. Let's check the off. If it's off, 0 and reply, and we will continue. This is correct. Should be correct. Maybe you need to reset the UNO. UNO off. Why I didn't get my message from the UNO? UNO should print ready. Hello. Why doesn't print the ready? Oh, did I delete it? No, it's here. Anyway, This one correct. Let me upload the correct thing. There we go. It's done. There we go. Ready is here now. There we go. Some issue with the code previously. Oh, when I close and open again, it doesn't reset. Whatever. Okay. So if I said hello, now you should say hello 4 from Pico. If I said on again, so on. Okay. If I said off, I should get off. Why I get hello 4? I don't think so because of this. Because if I send any other data, it's correct that when I set off, it will resupply the old one. Oh, damn. If you see the reply here, I got the 2 replies. 1 reply here, 1 reply here. That's why this extra one. Sorry, guys. This is the issue. Again, on should be LED on, off, LED off. Nice, pretty, and sweet. Okay, so now we're done with Pico. Pico now is a response switch with our on and off, to turn on and off the LED. So now is the UNO side. So the UNO, you see now, it will be fixed on, off without any counters, or easy for us to keep tracking it. Okay. So now here I will, where we receive, this is the received data that bring the string. So here we go. So here I will check if my string or the received string is equal to on, so here I need to turn on the LED, or if my string is equal to off, so here I need to off my LED. But before that, I believe we need to declare the LEDs. Did I declare the LED? I don't think so. So setup, in the setup, we need to, okay, let's declare it here. So clean mode, LED, this for built-in. So I want it to be output. Okay. So I want the built-in LED to be output, and down there, where here. So here I want to have digital right. This one will be built-in LED. LED underscore built-in. If on will be 1, and this one is in colon, and if off should be 0. Yeah, exactly. Let's see. I believe should be okay and correct. We didn't do any mistakes. Yes, it's uploading now. Cool. Our UNO is ready. So here we go. We send on, we fix back on, send back LED on, and our LED doesn't work. Why? Okay, let's check it out. When we send on, why the on doesn't work? Oh, sorry. Here should be the new line. We didn't strip it, because if you remember back there, here we didn't strip any data from the string directly. The received string we compared it. So we didn't strip. We didn't take out any the new line thing that's been embedded at the end of the command, because if you see here, we added a new line, okay? So now done, UNO ready, so I can on. Here we go, we did it. So hello, anything we send, we just send us back with a counter. Hello again, should be 2. If I send off, this should be off, boom, off. Here we go. Nice. So now again, I send data from the hardware serial through the soft serial to the Pico, then the Pico will process it. If whether it's on or off, will be toggle the LED. If not, we just concatenate the counter and send it back to the UNO. Cool, that's cool. Happy with this. So we can on, here we go, on, and if I send off, off. That's good for that. I hope you have learned something with me, guys. So here is how we play with the UART of the Pico, which is targeted for Pico, not for the Arduino UNO. So yeah, now I believe we are ready. After this tutorial, we are ready to play with our friend RS module. Okay, so because as I told you, I promised you before, I want to change the UNO or the Raspberry, the what they call the Arduino with the Raspberry Pi. So Raspberry Pi or this Pico will be my master for the RS communication and Modbus protocols. Okay, so thanks guys. I hope you have learned something from this tutorial. Keep it up and happy learning.